Okay, so we're going to finish up with Unit 7, Lesson 3. This is Part 2. It talks about parallel lines and proportional parts. And once you're done with this, then you're going to go to page 199 in your workbook, and you're going to go to 1 through 10 to, get through the parallel line and proportional part stuff that you have to do for this section. So let's go ahead and finish the notes. If a line is parallel to one side of a triangle and bisects the other two sides, then it bisects those sides proportionally. So this line, GH, is proportional to, or parallel to EF, and it bisects ED and FD. And so if GH is 6 and EF is 12, then we can use this information to find the missing measures of the other two sides, because you can tell it's a smaller triangle and a bigger triangle like we talked about in previous pieces. The other thing that is true is if we know that this is 4, then this is going to be also 4, because the whole line is going to be 8. And so, obviously if this is 5, then this is also going to be 5. Alright? But there's lots of different things that can go on here for us to look at. So let's go ahead and take a look at them so that we can understand how this works. So obviously we have the easiest example, and that's the one that was right here in the top of the notes. But if this is, for example, 9 and 6 and X and 9, if these two lines are parallel, then we can set up the proportion 9 over 6 is equal to X over 9. Okay? And so then we can cross multiply and solve, and when we do all of that, we're going to find out that X is equal to 13.5. Okay? Let's do the same thing, but just make it upside down. If these two lines are parallel, and we have, well, let's just go with 12 and 9 and 16 and X, then we can do 12 over 9 is equal to 16 over X. We can cross multiply and solve, and what we're going to find out is 12x is equal to 144, x is equal to 12. It also works really with any triangle that we have. So let's draw a non-standard triangle, just an obtuse one here, and cut it this way, and these two lines are parallel, and let's use 7 and 10, and let's use X and 6. And let's do another non-standard triangle, but let's even, here we go. These two lines are parallel. Let's do 4 and X and 6 and 11. So go ahead and set up proportions and solve. Go ahead and pause the video now and solve for X in these two examples, and then go back over the answers. Okay, so for number 3, you should have had 7 over 10 is equal to X over 6. You cross multiply and solve, X is equal to 4.2. For number 4, you should have had 4 over X is equal to 6 over 11. You cross multiply, you get x is equal to 7.3 repeated. Hopefully you don't have any questions there about how you can set up with two triangles. Okay. The other part of this rule, though, is if two parallel lines intersect two transversals, then they bisect the transversals or intersect the transversals proportionally. So, and I'm sorry, we're going to change this to 3. We're going to change this to 3. If 3 parallel lines intersect two transversals, then they intersect the transversals proportionally. 2 or 3, it doesn't matter, but it's going to take 3 to do what we need to do in the picture. So we're going to draw 3 lines like this. Make them smaller as they go. And essentially, if these 3 lines are parallel, then the same rules apply. So like we can make these big numbers. If this is, I don't know, let's say 15, and this is 9, and this is 12, and this is x, we can still set up proportions. 15 over 9 has to be equal to x over 12, because this thing's breaking this group up proportionally. So we do 15 over 9 is equal to x over 12, and we get 9x is equal to 180, so then x is equal to 20. Okay. That works no matter what our shape, what our shape is. We can turn this thing this way. So same idea. These are parallel. I'm going to go ahead and make it 72, 30, x, and 24. Go ahead and find that missing side. We're going to create one more here. We'll go this way. I'm going to do 12, x, 8, 24. Go ahead and find that missing side. So go ahead and pause the video and set up your proportion and then solve. Okay, so hopefully you set up the correct proportion here. You should have 72 over 30, or you can have 30 over 72, or you can have 30 over x, wouldn't really matter. And then you have 24 over x. Cross multiply, you get 30x is equal to, let's see, 72 times 24. Oh, I'm sorry, no you don't, you get 72x is equal to 600, 720, and so x is equal to 10. Over here you get 8x is equal to 288, and then when you divide by, oh I'm sorry, we better show you the proportion first. 12 over x is equal to 8 over 24. Then we divide by 8, you get x is equal to 36. Again, just standard proportions and then solve, what we've done in the entire chapter. The last one is just more of the same. If a segment bisects an angle of a triangle, then it bisects the opposite side into segments that are proportional to the other two sides. So this also should back up our other theories. But let's say we know that this is 9 and this is 6. And we have this angle right here, this line, and it bisects this angle right here. If we know that this is 4 and we're trying to find this piece, well, we can set up a ratio because essentially this triangle is similar to this triangle. So 9 over x is equal to 6 over 4. We cross multiply and we find out x is equal to 6. Okay, so I'm going to create 2 more examples, and I want you guys to do them. So this is 15 over x plus 1 and 12 over x. This one is 16 over 8 and 2x over 7. So go ahead and set up the proportions and solve. Alright, hopefully you set the correct proportions and solve, but here it was 16 over 8 is equal to 2x over 7. You get 16x is equal to 112. Then you divide by 16, you get x is equal to 7. Hopefully you set up the correct proportion over here. 15 over x plus 1 is equal to 12 over x. Cross multiply and solve, you get 15x is equal to 12x plus 12. Subtract 12x. X is equal to 4. And sure enough, 15 over 5 is equal to 12 over 4. And so that's the correct proportions. Okay. So I'm actually going to amend this work a little bit, and if you follow along with the video, I'll know you were able to do it. It is going to be 1 through 10, and then 13 through 15. So you're going to have to complete 1 through 10 and then 13 through 15. And again, 1 through 6 is just making sure you can set up proportions correctly. And then 7 through 10 and 13 through 15 are actually setting the proportions up and solving. If you want to challenge, 11 and 12 are definitely ones that will challenge you because they involve factoring. And I'm not sure how many people remember factoring, but it's a pretty important part of math. And there's only going to be one answer. But we'll see. You guys can give them a roll if you want to see how they go. So when you check off these 15 problems, you're done with this section.